Hey everyone, in this video lesson we're going to be talking about the characteristics of parabolas. There is nothing that you're going to be learning here that we haven't already discussed in this class. So by now you should already know what all of these things or most of these things already are. But we're basically just putting everything together. So this kind of just sums everything up. So for every graph of the quadratic function, we need to identify the following. First, we need to figure out, does the parabola open up or does the parabola open down? So we can do that based on a few characteristics. 2, is the parabola going to be wide, or is the parabola going to be narrow or skinny? However you want to word that. 3, does the parabola have a maximum point or does the parabola have a minimum point? You could figure that out as well. Number 4, what is the y-intercept? So all of these you can basically figure out without graphing, including number 5, which is what are the coordinates of the vertex? The coordinates of the vertex is the x and the y, which is defined as h and k. We talked about this in one of the previous lessons. 6, what is the equation of the axis of symmetry? So they want the actual equation for the line of reflection. 7 and 8. 7 is what is a domain, which we talked about in this class in the past. And then 8, what is the range, which we also talked about in the past. And then I'm going to include a number 9 here that is not really included here, but it should be pretty obvious. 9 would be just to graph the actual parabola. Because a lot of these we can do without actually graphing it. It doesn't tell you to graph. But since the point of this is to practice our graphing, when it comes to quadratic equations or parabolas, then I'm going to add the graph in there so you guys can graph. Okay, so this is just going to be all a recap of everything that we've done in the past. So you're not going to get mind blown or anything if you paid attention to the last couple lessons. So example number 1 says graph the following quadratic function and then answer the questions regarding its characteristics. So graph the quadratic function and then answer the questions regarding its characteristics. So first we need to figure out whether it opens up or down. For that, we need to figure out what the value of a is. There are 3 values, right? So there's the value a in front of the x squared, the value of b in front of the x, and the value of c, which does not have a variable, in descending order, basically. So x squared, bx, and then c. So we spoke, well, we talked about in the past that the value of a will tell us whether it's wide or skinny. If the value of a is a fraction that is between 0 and 1, it's going to be wide, right? So right away we know that it's going to be wide. And if the value of a is positive, then we know that it's going to be going upward. So this is an example in which it opens up and it's going to be wide. It also asks for the vertex. So let's figure out the vertex. So the vertex is the point h and k. So h comma k. To figure out the h, the formula for in one of the previous lessons is negative b over 2a, or opposite b over 2a. Since we already have our a, b, and c from the equation, it's going to be opposite of 2 divided by 2 times a, which is 2 times 1 over 3. Okay, so we just have to simplify this out. When we simplify this, we're going to be getting, well, there's different things that we can do here to simplify. First thing we can do is, okay, let's just do the top. So negative 2, we're not going to mess with that. On the bottom, we're going to leave it as 2 times 1, which is 2. On the bottom, we're going to have a 3. Right? So now we have negative 2 divided by 2 over 3. This looks pretty weird. I'm going to go ahead and just bring back the top number is going to be negative 2, which another way of saying that is just negative 2 over 1 divided by 2 over 3, right? So I just put the division symbol. And the reason why I did it this way is because I'm going to remind you guys of something that you should have learned in like 7th grade or 8th grade or whenever this was. We could always convert this into a multiplication by using keep, change, flip. So keep, change, flip means we keep the first one the same, negative 2 over 1. We change this to multiplication, and then we flip the second fraction over, so we're able to simplify a little further. So if we do keep, change, flip, the 2 and the 2 would actually cancel, and we realize that the final answer is equal to negative 3 for the h. So the h is equal to negative 3. I could have done this a different way, but I wanted to bring back something you learned in the past. You could have also said in the beginning of the problem that the negative 2 and the negative 2 cancel, and then basically just take that 1 divided by 1/3, which will give you just negative 3. Whichever way you do it, it'll give you the same answer. Okay, anyways, so k. How do we find the k in the vertex? All we have to do is plug in that value of -3 to figure out the value of k. So into our original equation, of course. So let's find some space to do so. I'm going to go ahead and just do it on the left-hand side here because there's a lot more space. Notice that my equation is 1 over 3x squared plus 2x plus 4, right? So I'm going to be plugging it into that equation. 1 over 3x squared plus 2x plus 4. But instead of the value of x, I'm going to be replacing that value of x with the value of h, which happens to be -3. So everywhere you see an x, I'm going to be replacing that x with -3 and then simplify. All right, so remember the order of operations. First we square it, then we multiply. So this is going to give me -3 squared, which is 9, and then 9 divided by 3 will give me a value of 3. So the first number that I get here is 3. The middle value would be 2 times -3, which is -6. And then finally, we do plus 4. Okay, so the first number is 9 divided by 3, which gives me 3. The second term is 2 times -3, which is -6. And the last term is we just drop down the 4. All in all, this gives us a final answer of 7 minus 6, which is 1. So k is equal to +1. So that means that the vertex, which we established was the value of h and k, we're going to be plugging in the values of h and k, which is going to be -3 and +1. So my vertex is -3. I'll write it up here. Vertex, -3, +1. And there we go. Okay, so I'm also going to write it on the left-hand side because on the left-hand side, this is where I have all my characteristics that I have to fill out. So the vertex is -3, +1. Is the vertex a maximum or a minimum? Well, we already said that the parabola was going to open upwards, right? So if it opens up, that means that it's going to look something like this. That means that the vertex is going to be at the bottom, which means that the vertex is a minimum. So then, therefore, this vertex will be a minimum. Next thing we need to find is the y-intercept. So the y-intercept is where it crosses the y-axis. Also, this is another way to find the y-intercept always. We set x equal to 0. So if we do that, if we set x equal to 0, so 0 goes here and here, the only thing that we're left with is the number 4. So my y-intercept is going to be +4, right? So when I plug in 0 for everything for all the x's, I should say, everything goes away except for the value of 4. So then my y-intercept will be 0, 4. Okay, we're going to put everything together in the graph in a little bit. My axis of, well, let's do that now. The vertex is a -3, 1. So we go to the left 3, up 1. So this will be my vertex. Let me color it red so it's clear. So there's my vertex. My axis of symmetry is my line of reflection, which goes up and down through that vertex. Right, so it's always going to be vertical going up and down through that vertex, and it does not change direction. It just basically goes up and down. If I want to figure out the formula for that line, that crosses the x-axis at -3, so it'll be x equals -3 for that line of reflection, which is the axis of symmetry. So the axis of symmetry here, another way of saying that is x equals -3 because it crosses the -3, right? So that comes out of the line of reflection or the axis of symmetry. The y-intercept is at 0, 4. So that means I start at 0 and then I have to go up 1, 2, 3, 4. So then my y-intercept is going to intersect right here at 0, 4. Okay. Let's finish graphing this. So I can reflect this y-intercept on the other side. 1, 2, 3. So there's 3 squares between this and the line of reflection. So I'm going to be going 1, 2, 3 to the other side. Okay. If I want to get a couple more values, in one of the previous lessons, I said you have to get your ax squared and then plug in x is equal to 1 and plug in x is equal to 2 to figure out what are some points around there that you're able to graph. So let's do that really quick. So my ax squared would be 1/3 x squared. So I'm going to be plugging into 1 over 3 times blank squared twice to see what I get when x equals 1 and when x is equal to 2. When x is equal to 1, I get 1 squared, which is 1, times 1/3, which is 1 over 3, or 0.333, however you want to define that. And then when I do the second one, it's 2 squared, which is 4, And then I get 4 times 1 over 3, which is 4 over 3. So I can write it as 4 over 3. So on the first one, we said it was 0.33. On the second one, 4 over 3, it's going to be 1.33. So whichever way you want to define that, but it'll actually help us get a couple more points when we're graphing. If you didn't understand what I just did, you should go back to another video. Different video is called graphing quadratic equations or graphing parabolas without a table or no table. Okay, so if this was unclear to you, basically go back and watch that other video. There was a ton of examples. So starting at the vertex, when we go to the right one space, we're going to be going up 0.333, which is going to be right there. If we go 2 spaces to the right, it's going to be 1.333, which is going to be right about there. I'm going to reflect those 2 values here and there. And as you can see, it actually matches with my parabolic shape. So then I'm going to go ahead and connect everything. And we are done. So this is my graph of my parabola. So y equals 1 over 3 x squared plus 2x plus 4. So that's the graph that it gives me. Now, the last thing that they want is the domain and the range. So we already did this in the beginning of the year sometime. So you should be familiar with domain and range. The domain of this interval will be from, there's an arrow going to the left and to the right, from left to right. Remember the domain is the x-axis. So on the x-axis from left to right, it goes from negative infinity to positive infinity. So I'm going to go ahead and write it in as negative infinity, positive infinity. Now, infinity is always going to have a parentheses, so parentheses, parentheses. The range is going to be from the bottom to the top on the y-axis, right? So if we look at the bottom of this graph, the bottom of this graph is a positive 1. And the top of this graph, well, you see arrows, so it never ends, so it's going to be infinity. So the bottom of this graph actually does end at that 1, so I'm going to put a bracket, and the top of this graph would be at infinity because it never ends. Okay, so these are all the different things. We're putting everything together they can possibly ask you in regards to parabolas. And this is basically it in a nutshell. So does it open up or down? Is it wide or narrow? What is the vertex? Is the vertex maximum or minimum point? What is the y-intercept? What is the axis of symmetry? What are the domain and ranges for this graph? Okay. In math 2, they might ask you more things such as the x-intercepts. So example 2. So let's go ahead and get this done. However you want to do it, you can graph it and then answer the questions, or you can answer the questions and then graph it, either way. So this time I'm going to do it a little bit different. I'm going to go ahead and just graph it and then answer the questions in a bit. So first thing is the parabola, the a for the parabola is -5, which means that the parabola is going to be going down, and the number is bigger than 1, which means that it's going to be narrow or skinny, right? Since the parabola is going to be going down, that means that the vertex is going to be at the very, very top. So therefore, it's going to be a maximum value. So without doing any work, I already answered 3 of these questions. Now let's actually graph it and do all the other stuff. So let's find the vertex. So the vertex is going to be the h and the k. So h is equal to opposite b divided by 2a. If we look at the a, b, and c values, so a is equal to -5, b is equal to 10, and then c is equal to -3. In this case, we're going to be getting opposite of 10 divided by 2 times -5. Don't forget the negative. So that means that the h value would be -10 over -10, which is +1. So then my h is equal to 1. Okay, if I want to figure out my k, I have to plug in into the original equation, right? The original equation that we're talking about, that we're graphing. Everything in for x is going to be replaced with the value of h. So instead of the x, I'm going to be replacing that with the h, which happens to be 1 in this case. And then simplify. So my k value would be -5 plus 10 minus 3, which is 7. So it's -5 plus 7, so my k value would be 2. Okay, so I found my vertex. My vertex is hk. So my vertex is 1, 2. And that's actually one of the questions that they're asking on the left-hand side. So the vertex is 1 to the right and 2 up. So starting at wherever you want the origin, actually no, not wherever you want. You always start at the origin, you go 1 to the right and 2 up. So this is my vertex. Okay, from there, we're going to draw the axis of symmetry, or the line of reflection. So the line of reflection is just a line going up and down through that vertex. So when I make my line going up and down, this line crosses the x-axis at the number 1. So the axis of symmetry is x is equal to 1, positive 1, right? Because it crosses the x-axis at 1 from that pink line. That's what that means, okay? Let's figure out what some other points are when I need to graph this. So let's use our ax squared, and then we're going to be using x equals 1 and x equals 2 to figure out what are these values. So the ax squared in this case will be negative 5x squared. So we're going to be using two values, negative 5x squared with x equals 1 and x equals 2 to see what we get. So that's exactly what we got here. X equals 1, I plug that into there. And then x equals 2, I plug that into there. And again, if you're having trouble understanding where I'm getting this, go ahead and look at the other video that I've posted, graphing quadratics or graphing parabolas with no table. All right, so now that we have this, the final answer for this will be negative 5. And the final answer for this, first we have to square it, then multiply it. So this will be 4 times negative 5. 5 times 4 is 20, so this will be negative 20. Okay, so that means that when I go one space to the right, I have to go down 1, 2, 3, 4, 5 spaces. And when I go 2 spaces to the right, I have to go down 20. Jeez. So 2 spaces to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's off the page, big time. I'm just going to guesstimate. 18, 19, that's about 20. Sure, why not? So it's a guess, but I mean, if you get off the grid, don't panic. You just do what you can. I'm going to go ahead and reflect these points on the other side of the line of reflection. So that means that there's another point here, and there's another point right about there, give or take. When I connect these points, try to make a parabola the best you can. Oh, don't be like me. This looks terrible. Self-destruct. Jeez, terrible. So again, this should look like a U. Sorry, I'm using a computer, so it's not going to be the best parabola shape possible, but you get the idea. So in this case, we have the vertex, which is a maximum, like we predicted. The y-intercept is going to be here on the y-axis, which is at 0, negative 3. So I'm going to go ahead and write 0, negative 3. The axis of symmetry is at x equals 1. The domain is from left to right, right? The domain is the x-axis. From left to right is still going to be arrows going to the left and the right. So it's going to be negative infinity and positive infinity for both the left side and right side. And then the range is going to be from the bottom to the top. The bottom, I see arrows. So the bottom would be negative infinity because it points to the bottom forever and ever. But it actually ends at this value, which is the maximum value or the vertex, which is positive 2. So I'm going to go ahead and end that at positive 2. Okay? So these are some characteristics of this specific parabola. And you could actually check your work with Desmos or plug in some values. All right, is there more? Oh my God, I'll give you 4 examples. Okay, I'll try to make it quick. Example 3, same idea. So example 3 is this parabola going up or down? So the value of A is negative 1/2. I can see that it's going down because it's negative, and I can see that the value of 1/2 is less than 1, which means that it's going to be wide. All right, since the parabola is going to be opening down, right, meaning this way, that means that the vertex is going to be here, which is a maximum. So that means that the vertex point is going to be a maximum value. Now we just have to find it. So the vertex is going to be the point h comma k, and then the h is found with the formula opposite b over 2a. Opposite b in this case would be opposite of the value of 2, right? Because this is the a, this is the b, and this is a c. So opposite of 2 would be opposite of that number. And then divided by 2 times a, which in this case the a is negative 1/2. So negative 1 over 2. All right, so let's simplify this. So on top we get negative 2. On the bottom we get the 2 and the 2 cancel, so we're left with just negative 1. So then the h is equal to the negative and the negative cancel, so we get positive 2. Cool, let's find the k. So the k is whatever we get when we plug in h into the original equation. So this is the original equation that I started with. Let's go ahead and rewrite that, but instead of the x, I'm going to be writing blanks. So everywhere you see an x, you're going to be putting in a blank. But then we're going to have to fill in these blanks with the value of h. So the value of h in this case is equal to 2. So we're going to be substituting 2 here and there. Okay, so we have 1/2 multiplied by 4. Actually, I can do that in my head. So 4, 1/2 of 4 is 2. And then we add 2 times 2, which is 4. And then minus 3. This is going to give me 6. So 6 minus 3 is going to give you the final answer of 3. So my vertex, HK, is also equal to the point 2, 3. So HK is 2, 3. So on the left-hand side, we're going to write on the vertex 2, 3. Cool. The y-intercept. The y-intercept is where x equals 0. So when we plug in 0 for everything, what's left, right? So if we plug in 0 for the x, we plug in 0 here, plug in 0 there. What's left? The only thing that's left is the value of -3. So my y-intercept is -3. Okay, so let's go ahead and start with that. And then we'll move on to the axis of symmetry, then in the domain and range. So we know the vertex is at 2, 3. So we start at the origin, we go 2 to the right, and then up 1, 2, 3. So that's my vertex, right, according to the vertices that I had here. Also, we're going to be drawing the axis of symmetry, which is a line of reflection. So make a line going up and down vertically through that vertex, through that point every single time, perfectly straight. And if you wanted to find the equation of the line, well, that equation crosses the x-axis at the number 2. So the axis of symmetry is x equal 2, right? So that is the line of reflection that we just drew. Okay, the y-intercept that we had already found is at 0, -3. So we start at 0, then we go down 1, 2, 3. So we're going to put a point right here because that's the y-intercept. Now, if you want to get ahead of me, you can and say, okay, since this is my y-intercept here and it's 2 spaces from the line and parabolas are symmetric, then I should also have another dot 2 spaces to the right, since I had 1 2 spaces to the left because it's symmetric, right? If you want to make this more like precise, you can. As it is, I could already make a graph, right? I can already make this graph as is and answer the rest of the questions. So if I make this graph going this way, the domain and range, the domain is from left to right. As you can see from left to right, the left side of this graph would be -infinity because you see an arrow. The right side of this graph is +infinity because you see another arrow. And infinity will always be parentheses. The range is from the bottom of the graph to the top of the graph, right? So this will be the y for the range. So the bottom of this graph will be -infinity because it never ends. So that's going to be a parentheses. And the top of this graph will be the maximum value, which is in this case +3. Since at the top we actually have a vertex or a point, this is going to be a bracket. Okay? So there you have it. In this case, I didn't need the additional points, but you could have also gotten additional points by doing what I just did earlier, by using the ax squared and then plugging in x equals 1, x equals 2 to get some additional points to make this graph more precise. But if you're just doing it to answer these questions, you can go ahead and just, if you're able to do it with just the y-intercept, you're able to basically graph the whole thing. Example 4. Last one, just so I can speed it up and call it a day. Graph the following quadratic function. So in this case, let's look at the value of a. There is an a, right? This is my value of a. My value of b is -20, but there is no c. So that means that c equals 0 or it's basically gone. So we don't really need it for anything in this case. So the a is 10, which means the parabola goes up. 10 is way bigger than 1, which means the parabola is going to be very skinny, very narrow. Okay, and that means that as the parabola is going up, right, that means that the vertex is going to be the point that's at the very bottom, which means that the vertex is going to be a minimum point. So I could already circle this as going to be a minimum point. Now we just have to find the vertex, the y-intercept, and all that stuff. So let's start with the vertex in no particular order. So the vertex is the point H and K. Again, same process, h equals opposite of b divided by 2 times a. Opposite of b will be opposite of -20, divided by 2 times a, which is 2 times 10. This will give me 20 on top, 20 on the bottom, which means that h is equal to the number 1, +1. If I want to find k, I'm going to do this on the opposite side, so there's space. Same exact process. I'm going to be plugging it into this specific formula, right? So the one that we're working with at the moment. So 10x squared minus 20 times x, but instead of the x, I'm plugging in the value of h, which in this case, the h is equal to the number 1. So everywhere you see an x, we're replacing that x with the value of 1 and simplifying. So then k, we're left with 10 minus 20, which is going to give me negative 10, right? So my vertex is h and k, therefore it is 1, negative 10. So 1 comma negative 10 for the vertex. The y-intercept, to find the y-intercept, we set x equal to 0. If I set x equal to 0, everything goes away. So therefore my y-intercept will be at 0 comma 0. Okay, so let's start with what we already have. We already can basically graph this. So if we were to go ahead and graph this, the vertex is at positive 1, negative 10. So we go to the right one space and then down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that'll be right there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's correct. I'm going to go ahead and draw the axis of symmetry, which is the line of reflection. So make a line going up and down through that point perfectly vertical. And the equation of this line, it crosses the x-axis at the number positive 1. So then x equals 1 would be the equation of my axis of symmetry. Okay. Now we already found that my y-intercept is at 0, 0, which means that it's going to be at this point right there. Since I have my axis of symmetry here, that means that there's going to be another point on the opposite side, which means there's going to be an opposite point right there. So I can basically graph my parabola as it is. Now I know it's going to look ugly. Bear with me. I'm trying to do this on the computer. Oh, here we go. But essentially, this is the graph that we get. So the graph is a very, very, very skinny, right, or narrow parabola that is going upwards. And the vertex of that parabola is at positive 1, negative 10. So this is exactly what my predictions stated. All we have to do is find the domain and range. So the domain is from left to right. It's still going from negative infinity to positive infinity from left to right. So negative infinity, positive infinity. And then the range is from the bottom to the top. The bottom of this graph happens to be at negative 10. And there is a value there, which is called the vertex, the minimum point. The top of this graph never ends, right? Because we have arrows on top. So it's going to be all the way to positive infinity. So there you have it, guys. You have figured out how to graph parabolas and figured out what are some very important characteristics of parabolas that they're probably going to ask you guys on a bunch of different tests. I hope this was helpful. See you guys in the next one.